For this next lesson, we want to use the supplied file MCU3D gas pedal verify. We're going to be taking a look at some of the different aspects of using verify in the Mastercam simulator, and I want to point out a few things before we get started. First, I want to note that there are several different machine groups and toolpath groups in this file. We have one for a Haas VF5 axis because there are some multi-axis toolpaths in here. We also have one for a Haas VF2 that contains toolpaths for the fixture. We're going to be exploring a couple of the different options and ideas and ways that we can use this information. I also want to note on the Machine tab that there are a few different areas that we want to talk about in here. We have a Simulator area, which talks about the Mastercam simulator, Backplot, which runs directly inside of Mastercam, Verify, which will open up the Mastercam simulator, and then we also have a machine simulation. There are some different functionalities that happen between these, so we want to talk about these and make sure that we understand them. The first thing that we're going to talk about is using Verify. In order to use Verify, we need to understand the setup process. So I want to note that setup 2 is machining the opposite or the top side of this part, what we see in red here. In order to simulate that with Verify, I first want to go into my simulator options. I'm going to pull this over to the side, and the one thing I want to note here is that we can start the simulation based on a stock model. So I want to grab the stock model from setup 1-5, and what this is going to allow me to do is use that information to start, so I don't start with just a solid block, and this will help me understand what material has already been removed and what we're focusing on. I also want to note that we can use fixtures in here. So we want to make sure that we're using the fixture for setup 2. Note that there is a level 205 that contains a Kurt vise and a level 201 that contains a fixture for setup 2. So we're going to be using both of those, and if we expand our levels and show level 205 as well as level 201, you can see that we have a vise and we also have that fixture that's contained there. So when we use Verify, we want to select the toolpaths we're interested in. So this can be either an entire machine group or we can select individual toolpaths. Once we do, we can use the Verify selected operations, or we can select it from up here as well. So let's try it from both locations and make sure that there are no differences. When we select Verify from our Toolpath Manager, a secondary window will pop up. This window contains the Mastercam simulator, and the Mastercam simulator has lots of different options that we want to talk about. First thing I want to note on the screen is the vise and the fixture and how they're displayed in green, and the stock that's displayed in gray based on the stock model. So you can see that material's already been removed and that we have what's left on the screen from the end of setup 1. In the top section, we have the typical tabbed interface that we note inside of Mastercam 2020. At the top left, we have Backplot, Verify, and Simulation. We can navigate between these 3 different modes. We're going to stick to Verify for this specific lesson. We also have stop conditions. Note the several different options that we can use for stop conditions: tool change, collision, tool inspection, and operation change. For this, I'm going to select tool change, and notice that it puts a check mark to the left. This button will have to be selected in order to use those stop conditions. Also note a few of the playback options we can use to create bookmarks and create automatic bookmarks. This will save the simulation state at timeline. We can display different parts of the tool. For example, I'm going to turn the holder off to get a better view of maybe smaller parts. We can change what's seen on the screen. We can also change to show those in a or completely remove them if needed. We can show the original workpiece. We can show or hide fixtures. We can also show the initial stock. So these are various options that we can use to change the way that things are displayed on screen. The operations will let be all operations, an operation, or segments of an operation, and we can determine whether or not we want to follow the tool, to trace it, or to do both. I'm going to turn on trace, and I'm going to start playing through this animation. So you can see as we're going through, We can display what's on the screen, and you can see that in yellow, what we're doing is we're actually removing the material. Let's go ahead and pause this real quick. As we pause it, what we've done is we've faced the top section of that part. In the bottom, this timeline can be dragged forward and backward. We can zoom in and out on various segments, and we can see an overall timeline here. The vertical lines are representative of a change, in this case a tool change. If we go to our view section, we also have several other options. We can do things like focus on the workpiece, we can focus on the tool, we can focus on multiple, and this changes the way that we identify what we're looking at. We can also change and tile the views. If we want to view it completely from the side, for example, we can set up a second view to show that. We're not going to go through everything here, but I do also want to show on the right-hand side that we can show a collision report, move list, compare, axis control. These are all things that will display on the right-hand side. The collision report is a tab at the bottom. The move list is showing the current tool, the move ID, the elapsed time, its position, as well as information about its feed. There's also a specific Verify tab. This allows us to change the way that the model's displayed, whether or not we want to show a 3/4 view or clipping, and this will make a lot more sense, especially if we're using a turned part and we're trying to look on the inside of it. But we can turn on clipping. For example, we can clip the front or back, and we can display this while the animation is happening. So if we rotate this around, you can see a solid view of what the inside of that part looks like. I'm going to turn that clipping plane back off, and also note that we do have some analyze options. We can keep the chips, we can remove the chips. We can also do things like compare. So we compare the results of an operation or group of operations to an external STL file. So this can be pretty handy, especially if we are checking against potentially an inspected model, if we're looking at the difference between a cast model and the final model as well. And we can save the stock out as STL at various points in time as well. We have a turbo mode, which allows us to speed the process up. So what happens is we'll actually get a coarser precision during the processing. So this can be useful for larger files. And we also have some options down here where we can speed up or slow down the playback. And we also have a slider that allows us to increase or decrease the precision. So notice that as I move the precision around, it requires a simulation to be reset. So I'm going to say OK, and it starts over because it has to recalculate the material that's been removed. Since we've just faced the top of the part, it doesn't make as much sense, but it does affect things, especially when we get into rounded corners or dealing with curvature. I also want to talk a little bit about the playback color loop option. So we can change the color that gets removed. In this case, yellow is the default, but we can change the color of the areas that have had a machining operation. And in this case, when we turn it on, you'll notice the timeline changes. So once we have that tool change, it will be purple and then this pink color. We can also change it instead of by operation, by tool. So if the same tool is being used for the entire thing, it'll all display as yellow. In this case, the operation and tool actually are the same, so we're not going to see any difference there. But let's go ahead and just play back through this. I'm going to speed it up as fast as I can. And we can also use some of the playback options to jump ahead to the next operation or all the way to the end. Since we've let it play for a bit, I'm going to go ahead and pause this, and I'm going to jump to the next operation. So it'll go from this initial opti-roughing operation that's clearing out the rest of this material, and you will notice that even if we're jumping, it's playing back some of the animation. So what that means is it's taking a little bit longer to process the actual model in relation to the simulation, but overall the process happens quicker. We're just not seeing all the material removal with the tool because it doesn't have to update the graphics constantly. It's able to get through the process a little